Hey guys, welcome to this video on wallets in Ethereum. And if we want to think about a wallet in the sense of a blockchain game, just think of it as something that is going to hold assets just like our wallets hold assets. So these can be in-game tokens, these can be NFTs, these can be any type of other logic that we are, creating in our Solidity contracts that are going to represent the player in some way. So this video is taken from the article Ethereum Game Development Working with Private Key, Public Key, and Address using Ethereum and C#. And there's always a link to the article in the description of this video. Okay, so for some house cleaning, I have a project here that we set up. Did this via the command line, and there's previous videos that you can follow that show you how to do this. Now we have a project up and we need to install the necessary .NET packages in utilities. So I'm just going to kind of get myself started here, and we'll just call the .NET add package Nethereum Web3. And I have a specific version of 4.21.2, and we'll just hit install. And why can't I do that? Okay, let's change into the wallets. There we go. And then we'll just clear and add that package. Okay, things are looking good there. I'll clear this out. And then we're going to add the hex package. Okay, and that's good. The util package. And the HD wallet. This gives us like the word list, and that represents the private key. Okay, so this failed. And if we see here, it has a specific version. So let's take this version here and we'll go through hyphen version and pass in a specific version. Okay, perfect. Right, so we're good there. So now we're going to get into, generating the private key and getting the word list. So a private key is a 256-bit number that is randomly generated using something called entropy. It's really crucial for you to tell your players that they need to, keep this thing secure, and try to add it into kind of like a game mechanic. So when you generate a word list, you can use this as kind of like a progression system in the early on tutorial in the game. So say that they're doing specific tasks, and you can randomly pick, number 6 in the word list and have the player enter that. And that actually reinforces that you as the game developer know that the player has actually written down their word list, and that it's correct for them, right? And there's some urgency. There's a reason why they need to keep this thing secure. Okay. So let's go in and make sure that all the packages that we need have been added correctly. So let's add a using statement for an Ethereum hex converters extensions. This is just some utility stuff from Ethereum. We need an Ethereum.signer. Okay, and this is going to actually help us with the generation of the private key using Nethereum HD wallet. This is for getting the word list, and yep, that's all we need from that. Okay, so the first thing that we're going to do here is actually generate a random private key. So let's put a comment here, say generate a random private key. And then we'll just create a variable EC key for elliptic curve. This will equal ETH EC key dot generate key. All right, perfect. And now we can create a variable for our private key, and this is going to be equal to the EC key variable that we created. This has a get private key as bytes, and then we are going to take that to hex. Okay, so far so good. And now we can console.writeLine, and then we will have our private key, and this is the private key. Perfect. Now we can just run .NET run. .NET run. Oh. Make sure we save the file. Clear this, and then .NET run. Okay, great. Now we have a private key. So our next step here is that we want to generate a mnemonic. I always spell this wrong. Mnemonic from entropy. I'm not going to get into too much what entropy is, but take it into account that from a private key, we are going to derive a human readable way of being able to generate this private key. And using a word list is how this is done. Okay, so we have our EC key, and then we're going to get the private key as bytes, as we did previously. Now we want to generate the mnemonic. And this is going to be equal to a new mnemonic, the word list dot English, and then we're going to pass in the entropy. Okay, great. Now we can console.writeLine. This is going to be our mnemonic. So it's the string parts that you have problems writing, and then the variables and functions and everything else are totally fine. Okay, and then we'll pass in the mnemonic here. Okay, so we will clear this, and then make sure that we save it and run .NET run. Okay, so from this private key, it has derived this mnemonic, and this mnemonic is basically this private key. Okay, so this is really good, right? That's what we're looking for. This is what we expect. So the last thing that we're going to do is to derive the private key from our mnemonic. And how is this done? So we're going to say var wallet is equal to new wallet. We're going to take our mnemonic to string, and our second parameter here is null. And then the var account is equal to the wallet dot get account, and the account that we want to get is basically the first account, or the only account that we would have at this point. Var is the derived private key for this account, equals account dot private key, and then we can console dot write line derived, get this in quotes here, derived private key, and then the derived private key, just to save myself from possibly typing this. And then we will just close that, save it, we will clear and run .NET run. Okay, and here we have the account that's basically derived from our private key and then the mnemonic. Okay, so what's another thing that we can basically do from this is get the public address. So let's go through and just add in the Ethereum address that is basically generated. Ethereum address. Now this is more going to be the client facing component. So this is what the user is going to see. This is where you're going to, send assets to. So the first part that we are dealing with is really just the account management, right? And after that account management has been done, now we're looking at, okay, well, what's the public facing? Like, what is the user really going to be interacting with? And that's going to be the address. So we can just easily get the address, and this is going to be equal to the EC key dot get public address, and this is just a function that we can use, and then we can console dot write line Ethereum address, and this is just the address that we have from above, and then we'll clear this and run .NET run again. Oh, didn't save the file, so let me save it, clear, and run this again. And there we go. Okay, so now we have our private key We have the mnemonic that we have already addressed that we can use as a game mechanic for the player in order for them to understand that there's, a sense of urgency to, first of all, write this down and to use it as a game mechanic to maybe take specific random numbers of the actual mnemonic to ensure that the player has written them down correctly. And then the Ethereum address, which is the public address that we are going to send our tokens, NFTs, and other things. So this is just an introductory to account management, creating wallets, deriving public addresses from derived public keys. And I'll see you guys in the next video.